Imagine stepping into your coding environment, and right there, by your side, isn't just your usual editor, but like an intelligent partner, someone who kind of anticipates what you're doing next, suggests solutions, helps you write better code, and faster too. What if that wasn't some far off dream, but, your actual daily reality? Welcome to the deep dive. Today, we're plunging right into the really fascinating world of GitHub Copilot, that powerful AI tool that's genuinely reshaping how developers like you write code. Our mission. It's to pull out the most important nuggets of knowledge from a bunch of sources, specifically practice questions and the explanations that go with them, all geared towards the GH-300 certification exam. Think of this as your personal shortcut to understanding AI-assisted development, giving you insights into not just what Copilot does, but how it actually works, its huge capabilities, and, maybe most importantly, the responsibilities that come with using such a powerful AI assistant. And just to give you a sense of the depth here, the GH300 exam itself, it's pretty rigorous, typically around 100 minutes long, maybe 65 questions or so, and you need to score 700 out of 1,000 to pass. So the insights we're about to dig into, they come straight from the core knowledge you need to really get this tool. Okay, let's unpack this then. When we talk about AI-assisted coding, I think the very first thing that jumps out for any developer is, well, how much time it can save, right? We've all been there, typing out the same old structures again and again. This seems like where Copilot really becomes a productivity powerhouse.
Oh, absolutely. It's true. What's really striking is how Copilot kind of steps in to handle the more mundane stuff. That frees you, the developer, up for the more complex, creative problem solving. It's incredibly good at dealing with what we often call boilerplate code.
Boilerplate, right. That code that's essential, but ugh, so repetitive sometimes. Like setup functions, class definitions, those endless config blocks feels necessary but kind of tedious, doesn't it? Does Copilot actually make a real dent in that workload?
It definitely does. Our sources really highlight this. Copilot significantly cuts down on all that repetitive typing. It can generate those structured code blocks for you, saving developers just a huge amount of time they'd otherwise spend writing the same patterns manually.
Yeah.
It really speeds up development by automating a lot of that sometimes tedious foundational work.
Okay, so it's great for starting new things. But, developers spend so much time tweaking and improving code that's already there. How does Copilot help with something like refactoring? Making code cleaner, maybe more efficient?
That's a really important point. Copilot isn't just for writing new code from scratch. It's a powerful tool for improving what you've already got. Our sources explain it can suggest alternatives to existing code, maybe more readable versions, shorter ones, or even more optimized ones. This directly helps developers refactor for better readability and maintainability. And that makes the code base easier to handle, easier to scale later on. It's kind of like having a second pair of eyes, always looking for ways to make your code, more elegant and efficient.
That sounds like a huge benefit, especially on team projects. Clean code is just vital for collaboration, isn't it? But what about documentation? That often feels like the task everyone puts off, right? Until the very last minute, or maybe even after. Can Copilot really help there, or is that still fundamentally a human job?
It's true. Documentation can feel like an afterthought sometimes, but Copilot can actually be a bit of a game changer here too. It has this ability to suggest clear, descriptive comments, inline comments or doc strings, and it generates them intelligently based on the function's code itself. This really boosts readability and maintainability, especially for complex functions where you need to grasp the logic quickly. It's about making your code almost self-explanatory without you having to type out every single explanation manually.
Wow. So it's not just spitting out code, it's improving the whole development process around it. And I guess that extends to testing as well. Writing unit tests can be so time-consuming, making sure you cover everything, especially those tricky edge cases.
Indeed. The sources definitely emphasize Copilot's help with unit test generation. It can suggest a whole variety of test cases for your functions. That includes those critical edge cases, the weird inputs that might break things, and common error scenarios too. This ability saves a lot of time and helps improve your overall test coverage. But, and this is really important, while it suggests tests, developers absolutely still need to verify them. Check they're accurate, check they're complete. It's an assistant, not a replacement for good testing practices. But yeah, it gives you a fantastic head start.
Okay, so it sounds like Copilot is way more than just a code generator. It's like a full spectrum assistant across the whole development lifecycle. But how do we get the most out of it? Like for finding those really sneaky bugs, what's the best way to use it for that?
That's a crucial question. And one of the most effective ways Copilot helps is actually in spotting potential bugs. Our sources suggest the best approach isn't just asking, hey, are there bugs here? That's usually too vague for an AI. Instead, you get much better results by asking Copilot to explain the code step by step and then have it point out logical errors using comments. It acts more like an analytical tool then. It helps you uncover issues you might have missed by making the code's logic really explicit. It's a powerful analysis tool when you use it interactively like that.
That makes total sense. It's almost like having a super smart rubber duck that can actually talk back and tell you what might be wrong. And I imagine the quality of what it suggests really depends heavily on how we talk to it. We can't just toss a vague request its way and expect magic, can we?
It's exactly right. That brings us straight to prompt engineering, basically, the skill of writing good prompts. Our sources really hammer this home. The importance of detailed natural language prompts. If you want a specific, high-quality piece of code, you need to tell it the function's purpose, what goes in, what should come out, in as much detail as you can.
Right. So not just write some code, but more like write me a Python function. It needs to take a list of integers, make sure all the elements are unique, then sort them smallest to largest, and finally return that unique sorted list, something like that.
Precisely. Short or vague prompts. They'll just lead to generic, probably less useful results. The more context, the more specific detail you give Copilot, the better and more accurate its suggestions are going to be. It's really about clearly communicating what you intend, almost like you're explaining it to another developer. Give it clarity, it gives you precision back.
This paints a picture of a remarkably powerful partnership, but it also raises some really critical questions about responsibility, doesn't it? This isn't a set it and forget it kind of tool, is it? We can't just blindly trust everything it turns out.
That's absolutely right. And connecting this to the bigger picture, the human in the loop isn't just essential, it's completely non-negotiable. Our sources are incredibly clear about this. Developers are always, without question, accountable for reviewing all the AI-generated code. It's not optional. It's a fundamental responsibility that stays firmly with the human developer.
Okay, so whether it's just one line of code or a whole function Copilot suggests, you still have to put your critical thinking cap on. You're the ultimate gatekeeper for the code base. What specifically should developers be looking for every single time they accept a suggestion?
Every single time, yes. And critically, before that code gets committed, developers have to rigorously check for a few key things: potential performance problems, any logical errors, and especially security vulnerabilities. That check has to happen every time, no exceptions. It's all about ensuring the code is high quality, robust, and preventing any unintended, maybe harmful consequences from getting into production.
That's such a crucial point before committing, because if you don't have that proper oversight, there are real risks involved, aren't there? Things that could seriously undermine the project.
Oh, definitely. When we talk about responsible AI, the main risk of just using Copilot without that human check is that the AI might generate code with security holes, or maybe code with subtle biased logic. This could look like insecure coding practices, maybe accidentally hard-coding credentials, something you'd never want to do, or even algorithms that lead to unexpected, maybe unfair outcomes if they're not thoroughly vetted. Without careful review, these flaws could easily slip into production code, and that could lead to major problems down the road.
And it's not just about security flaws in the code itself, is it? Companies also need to be super careful about their own data, their intellectual property. How does Copilot handle data privacy concerns, say, in a company setting?
Right. This is where something called content exclusions becomes really important, especially for businesses.
Yeah.
The main reason for enabling content exclusions for Copilot is basically to stop sensitive or proprietary code from being sent to Copilot's cloud service. We're talking about things like internal business logic, maybe private encryption keys, or unique algorithms that are part of the company's value.
So companies can basically tell Copilot, hey, don't send the specific stuff, our secret sauce, out to the cloud, making sure their IP stays theirs.
Exactly. It's vital for staying compliant with data regulations and just protecting the company's intellectual property. It's a really critical control, especially in enterprise environments where data governance is, a top priority.
That makes a lot of sense. And I've heard there's a difference in how data gets handled between, say, the Copilot plan for individuals versus the one for businesses. Can you break down that AI data governance part? Why does it matter?
Yeah, there's a key difference mentioned in our sources that's really important for organizations to understand. The business plan, by default, does not use a company's code, the prompts and suggestions to train the underlying AI models. This is a crucial distinction. It's designed specifically to help organizations keep control over their intellectual property and make sure their unique code isn't being used to improve the general AI for everyone else.
Gotcha. So a company using the business plan can be pretty confident their proprietary code isn't feeding back into the system and training the next version of the AI.
Exactly.
Yeah.
Now, in contrast, the individual plan might allow training based on your prompts and the code completions it generates. While individual users can usually opt out or restrict this, the default setting might be different. So the business plan offers a much more controlled environment for companies worried about data governance and protecting their IP. This difference really highlights the different needs, for individual developers versus larger businesses.
Well, this has been an incredibly useful deep dive into GitHub Copilot. As AI tools like Copilot get even smarter, even more integrated into how we work every day, how might the role of the human developer evolve even further? Will it shift maybe from purely writing every line of code to becoming more like a conductor, or maybe an architect of these AI-generated solutions? And what new skills are going to be the most valuable in that, well, fascinating future? Something for you to ponder until our next deep dive.